Right, exercise 6.4, question 6A, part 1. 6B, part 1 and 2. So you have to show it here, otherwise you cannot see the diagram. Okay, so we have a triangle. I think I'll require the information from part A first. Can you tell me your answer for part A for vector AC? What do you have? B plus C. And there is another vector BC. What do you have for this? Negative B plus C. Okay, I assume that you've checked your answers. If O is the origin, they give us that OB is 5, 0, OC 3, 4. Express AC and BC as column vector. Okay, so AC as a column vector, right. Now OB is actually the same as vector B. Then OC is the same as vector C. From the diagram, that was all given to us. So I know that if I want AC in column vector must be B. Replace it with 5, 0 plus C, which is 3, 4. So this gives me 8, 4. Okay, Sophia? Just a direct substitution. The next they wanted BC. So negative B, put in the values for B plus 3, 4. So we get negative 2 and 4. So these are column vectors. Alright? Arif, Umar, you look confused. Anything they need me to clarify? Okay, yes? Sophia? When you are asked to show that an angle is 90 degrees, there are a few things that you need to know. What are some things that come to mind? Okay, yeah, it's a right angle. What else? What else comes to mind when we talk about 90 degrees or right angles? We need to gather all our thoughts before we can decide. Okay, Pythagoras theorem. What else? Any more? Okay, there is a hypotenuse. What else comes to mind about 90 degrees? Something about circles and semicircles. This is a revision. Okay, tangent to a circle is perpendicular to the radius. What else inside a semicircle? Angle in a semicircle. Okay, so these are the things that we learned for right angles. Then we want to see which one can help us prove that it is actually 90 degrees over there. Out of all these options, what do you think is the most useful for us? By looking at the question. Pythagoras. Okay, but for Pythagoras theorem, I will require the sides. I need to prove that the hypotenuse, the longer side, when I square, is equal to the sum of the square of the other two sides. So let's try using that approach. I will sketch out the triangle first. So this is C, A, and B. As long as I can prove that magnitude of AB square equals to magnitude, okay, so I put on if magnitude of AB square equals to AC square plus BC square, then I will have a 90 degrees, right? If only I can do that. Do you know how to find the magnitude of AB? Do you know how to find the magnitude of AC and BC? Yeah, you should. So let us write down the column vectors of any one of those that we know. AC. What is the column vector of AC? 8 and 4. Okay, and then for BC, it is actually negative 2, 4. So what about AB? Do we have AB? But we do know that O is the midpoint of AB, right? So what is the AB? Okay. AB I can write down that it is actually equals to 2B. Yes? Which is actually 2 of, and B, what did we say? It was 50. So it's actually tan 0. So this is tan 0. So now I've got all the column vectors, which means that I must be able to get all the magnitudes. Okay? So we are going to use converse of Pythagoras theorem, which I've emphasized a lot during our N-levels also. So this is the approach, AB square. Okay, you can choose to write it this way, or you can choose to write it this way, magnitude of AB square. They're the same thing. We find out what this value is. So this will be 10 square plus 0 square to give us 10. Obviously 10, right? Because it is simply 10 units horizontally, according to our diagram. So this will be 10 units. So next we have AC square. AC square plus BC square. This must be square root of 8 square plus 4 square plus square root of negative 2 square plus 4 square. So this is 64 plus 16 is 80 plus square root of 4 plus 16, 20. Square root 80 plus square root 20. See already? Hey, this over here is actually the length. This is actually the length, so I need to square it. So I need to square this, right? Because I'm looking for AC square plus BC square. So here I get 80, and I square it, and I square it. So this will be 80 plus 20, which is 100. I also made a mistake over here. There's a square, this is 100. Did I confuse anybody? Or you're okay this time? Yes? Okay, let me restart. I was confused just now. Let me restart. Okay. So scratch everything that I mentioned just now. I'll do it properly this time. So AB square is actually the square of the length AB lah. So I want to find the magnitude of AB, and then I square it. Inside this bracket will be the magnitude of AB. The magnitude of AB is given by square root of 10 square plus 0 square. Agree with this part? All okay? Jolene okay? Okay, Jolene not okay. So if we don't skip a step, do you know how to find the magnitude of AB? What is the magnitude of AB? Then you square root. Okay, so like this, 10 square plus 0 square. Am I right? Okay, now I want to find AB square. How much is this? Square the square root, right? So I will get 10 square, which is 100. Correct? Okay. Why must I square it? Because Pythagoras theorem tells me that C square equals to A square plus B square. I need to square it. Okay? Now that I've got AB square, I want to verify whether AC square plus BC square, I want to see whether it gives me the same value as AB square, which is 100 square. So now I'll go ahead with my working. AC square plus BC square. Now AC square, how much is AC square? Square root of 8 square plus 4 square, am I right? Then on the other side, BC square is actually the square root of negative 2 square plus 4 square. 10? So if I'm squaring a square root, might as well not write anything, right? So they cancel off. So 8 square plus 4 square is 64 plus 16, which is 80. Plus negative 2 square is 4. 4 plus 16 is 20, which is 100. Am I right? Or anybody lost? So at this point in time, we see that AC square plus BC square, it gives me actually AB square. Because these values are the same. So they are the same. Therefore, we can conclude that by the converse of Pythagoras theorem, angle ACB equals to 90 degrees. Okay? Besides this question anymore? For this homework? 8. Part A, B or C? That means C also lah. C okay. Okay, so here we have a quadrilateral. And the points given will be D, A, B, and C. Information given is that angle A is the same as BAC. This angle is the same as CDA. Okay, these two are same. And AD is 9/5 times of BC. AD equals to 9/5 times of BC. Question. Which one is longer, AD or BC? Based on this statement. AD longer, correspond to the diagram, right? Because 9/5 is more than 1. What else can you tell from this statement? The first thing that we can tell is that parallel. Okay, what are parallel? Xin Hui, what are parallel? AD parallel to BC. Notice that I did not write the vectors. I'm just talking about lines. These two lines are parallel. What is the second thing that we can tell? Always two things only. They are parallel and tell me about the magnitude of these two vectors. They are the same. So we write down that magnitude of AD equals to? No, it's not the same as magnitude of BC. It is 9/5 times of BC. You must be able to write these two things down. So first, AD parallel to BC. So let's put on the parallel lines. Put on arrows to show that they are parallel. Next, to show that ACB, this angle, equals to DAC. So how to show that these two angles are equal? They are alternate angles, right? Parallel lines. They are alternate angles because they are found inside the pair of parallel lines. So for part A, angle DA, okay. Since, because they didn't explicitly tell you that the lines are parallel, you need to show them that I know the lines are parallel. So we say that since AD is equal to 9/5 of BC, then AD parallel BC. You must state this first. I'll give you 1 mark. Now, since they are parallel, then I can conclude that angle ACB is actually equal to angle DAC. Alternate angles, parallel lines. Then this gives you the full marks. Next, for part B, explain why ABC, DCA are similar. So from the name, from the question, triangle ABC, triangle DCA. They are supposed to be parallel, right? Supposed to be similar. So, like I said, you must be able to identify the corresponding points, the corresponding lines, and the corresponding angles. So the name actually helps us a lot. Do we see angles that are already the same? Definitely. We see this red angle and this red angle. So what are they called? Angle CDA, right? CDA over here. So C, then D, then A. CDA must be equal to angle BAC. And this is given. I've got one angle already. We've also shown another angle, right, in part A. And in part A, we say that they're alternate angles. So angle ACB equals to angle DAC. So this one was, I don't want to say the reason, same reason again. Very waste time. What should I say? Shown in part A, I can say found. in part A. Save a little bit of time. Okay? Since these two angles are the same, then do you want to go on and mention a third angle? Need or don't need? No need. Because the third angle, confirm angle sum of triangle must be the same already. But this is the recommendation from this angle over here in green. So I say that angle DCA equals to 180 degrees minus the first two angles. So, yeah, not DCA, DCA, yeah, okay, CDA, then minus angle DAC. So reason, angle sum of triangle. Then we see that actually DCA is the same. We've got a corresponding angle of ABC, which is actually also 180 minus. Then CDA, we found that it was the same as BAC minus angle DAC, which is ACB. So again, angle sum of triangle. Since all these are the same, these are the same, these are the same, then of course our remaining angle must be the same. So we conclude that angle DCA must be equal to angle ABC. Then, since three pairs of corresponding angles are equal, we say that triangle ABC and triangle DCA are similar. You must have this word similarity. Can? That is what I expect of you. Why do I want this? Because in our congruency test, what are the tests that we have? Recap, review, SSS, what else? ASA, what else? SAS, and one last one? RHS. For similarity, now that our Maths HOD has allowed us to use this acronym, what are the three tests that we have? So obviously AA is one. What else? What else you remember? No ASA. There is SSS. One more. SAS. Okay? Then we see that these two they appear to be the same. Then these two also appear to be the same. So this is why you must state congruency when you are listing, when you are stating the reason, similarity. So you must list it down also. Can? So we shorten some things for you, but we expect a little bit more from other parts. Then next, to find part C. Find the area of ABC over DCA. ABC, the area, divided by this area. So how do we find the ratio of these areas? Like I said, this must be a 5 second. Okay, give you a chance. 5 second. 5 second answer. Now, before we do the 5 second answer, I need to use this information. AD is 9/5 times of BC. We know that AD is longer, BC is shorter. Which one is 9 units, which one 5 units? This one must be 9 units. This one must be 5 units. Now that I have the ratio of side, can you tell me the ratio of area instantly? So what are they? What are they? Instantly, tell me, come on. Tell me the values inside here first. Okay, so this one is 25, this one must be 81. Okay, then the question was A, B, C, small over big. So, answer? 25 over 81. Next question. Any more? Or are we done with the homework already? 11. 9. Okay, let's start with question 9. Which part? 9C. Can you tell me the answer for part A first. EF equals to 1/3 U. Okay, and then we've got CG. How much is that? V minus U. Minus U. Okay, now part C. Find the ratio of CG to CE. Draw the diagram. This is a rectangle, right? So I know that AB must be equals to DC. And likewise AD must be equals to BC. Then they divided this into 3 equal parts. This is point E, and this is point F. And join this up. This is G. This vector is V. This vector is U. They also told us that you're supposed to prove that triangles are similar. I remember that I taught you must be sensitive to this kind of diagrams. Okay? Because these are similar triangles when you have parallel lines like this. The other one will be like this. There are also similar triangles over here. So do you see either of this shape inside your rectangle? Yes, okay. And they are here. Alright? Which is what the question asked you to prove earlier on. EFG is similar to CGD. Alright, CDG. Yeah, CDG, yes. Next, find the ratio of CG to CE. CG to CE. Then I want you to list down or write down the ratio of sides. Do you know the ratio of sides? EF to DC, how much is it? EF to DC? 3 and 1. Okay, so this is 1, then this must be 3, right? Okay, those are the corresponding sides. Can you tell me the corresponding side for example, EG? What is the corresponding side for EG? Very good. For corresponding side for EG is actually CG. We can actually get that from the name of the triangle. Let me just put it down over here. So triangle EFG is supposed to be similar to triangle CDG. So when I asked EG, the side that is corresponding to EG, so it must be CG. Understand? So if this is 1 unit, so I use instead of red, I use blue this time. So CG must be how many units? If EG is 1 unit, CG must be 3 also, because they are similar. Then I'm going to use another color since I've got a triangle. So I need 3 sides. Put it over here. If this is 1 unit, then where is the corresponding side for GF? One more time? No, I don't think it's DG. GF. For GF, what is the corresponding side? Not GC lah. GD, yes. So this must be how many units? GD. 3 also. Now that I have the ratio of all the sides, I can also find the ratio of the area, right? What is the ratio of area? So ratio of area, I use black color. What is the ratio of side? 9. So this must be 9, this must be 1. So by doing this, I can tell all the ratios already. Now back to the question. They wanted ratio of CG to CE. CG, this side, to CE. Is your answer already there? So what is the ratio? Yeah lah, answer 3 is to 4. Part C. 3 is to 4. And finally for, do you need help for part D? D? Anybody needs help, raise your hand, otherwise I'll move on already. Okay, part D. Part D says express DE. DE in terms of U and V. Where is my DE? DE. Okay, so this vector over here, So instead of going from D to E, I definitely must go through some other way. Okay, so you want DG plus GE. Okay, do we know any of these factors already? DG? The 3-1 is the ratio of the magnitudes. DG, do I know DG? Yeah, it's V, it's given in the question already. Plus GE. G is over here, the green color portion. Did I accidentally erase something? Okay, so GE. I don't have the vector for GE. Then how? GE. So I need to express it in terms of something else again. What can I express GE in terms of? Okay, how? Yes, Junior? Can't hear you lah. Use EF. So GE is equals to GF plus FE? Is that what I'm saying? But then I don't know what is GF. I don't know what's. I know FE, but I don't know GF. Oh wait, I do actually. Right? Yeah, okay. It looks like it's gonna work. So GE is actually GF plus FE. Right? What, the GE? G is the same as GF plus FE. See, the intermediate point is F. Then starting is G, ending at E. So GE lah. Okay. So next, GF. Can you now express GF in terms of anything else? GF? No, GF. It's time to use one of these letters already, U and V. Okay, I heard 1/3 of V. Right? Okay, then plus FE. How much is FE? 1/3 of? Are you sure 1/3 of U or 1/3 of something else? Is it U? U is from the left to the right. But now I want FE. So negative U. So the answer will be 4/3V minus 1/3 U. Any other clarifications required? Okay, then I think it will be the last question already, 11. Go. Okay, right now, if OD is 4/5 of OM, then what can you tell me about OD and OM? The first thing that we can say. Come on. I'm repeating this a lot of times because it always comes out. OD and OM. So what can you tell me about these two vectors? OD parallel to OM. The second thing is that magnitude OD is equal to magnitude of OM. 4/5. You must write it this way. It's 4/5 of the magnitude of OM. So obviously, OM is bigger than OD lah. So how many parts should I divide my OM into? 5 parts. Okay, 1, 2, 3, 4, and 5. So I've got 5 parts over here. Where is my point D? Over here, right? So this must be D. Okay, so I join my B to D up. So here, I can write this is 4 and this is over here 1. That's the ratio. Okay, these are not too important. Let's go back to the question. OA equals to P plus Q. Oh no, wait, there's another part. ON is 2/3 of OA. ON equals to 2/3 of OA. So first thing I can tell is that ON is No. From this statement, I must be able to tell 2 things. First is that ON is parallel to OA. Next, ON magnitude is equal to 2/3 magnitude of OA. Okay, so I must divide OA into 3 equal parts. ON is supposed to be 2/3, so this must be my point N. Okay, now I have all my information. They also told us that OA is P plus Q. So from O to A, this is P plus Q. In addition, OC, P minus Q. P minus Q. So since it's a square, the opposite sides must have the same vectors. Now, A part 1. OD. So instead of going from O to D directly, I will need to express it in terms of something else. So give me another expression for OD. Information, all the information required in the diagram already. So OD can be expressed as whatever you know, just give it to me. I'm sure I can do something with it. No, OD is not equal to OA. There are different directions also. OD and OA. No, OD, come. What can you tell me about OD? You can refer to your textbook also, the question. In fact, it's written over there. OD equals to OM. No, not equal to OM. But it is 4/5 of OM. Okay? Alright, it's given, right? Now, 4/5 is simply a number. As long as I can find out what OM is, I will be able to get my answer for OD. So now your job is to tell me what is OM equal to. OM. Okay, hang on. OA plus AM. Okay, good. Now, 4/5 OA. Do we know that already? Yeah, it is P plus Q. Then now I've got to deal with AM. How much is AM? Half of OC, right? Right? AM is half of AB, which is the same as OC lah. Okay, so I continue. 4/5 P plus Q plus half of OC, which is P minus Q. Then it's just sec 1 algebra already. 4/5 P plus Q plus half P minus half Q. You mean, how do I know that AM is half of AB? Yeah. Because it's stated in the diagram, it's the midpoint. See? Midpoint. M is the midpoint of AB. Okay? So here we have 4/5. P plus half P. Okay, 3/2P. Q minus half Q plus half Q. So continue. Next step, we get 6/5 P plus 2/5 Q. Alright, so that's for the first one. Part 2, DB. Okay. So D to B. What can you tell me about D to B? Express DB in terms of something else. Anything you like. Then I'll work it out for you. Sophia, DB. From D to B, how will you get that? Okay, DM plus MB. Now DM, how much is DM? 1/3? 1/5 of OM, okay. Then plus MB, right? How much is MB? Half of AB, which is actually half of OC lah. Okay, P minus Q. Can? So OM, 1/5 of OM. O to M will be OA plus AM. I skip some steps, okay? OA will be P plus Q. Then AM must be half of P minus Q. we still have to plus half of P minus Q again. Alright? This part is the same as this. So my OM is divided into two portions, P plus Q over here, then plus half of AM, which is half of AB, which is AM, which is half of P minus Q. Okay, so add everything up, get the answer. So 1/5, P plus half P, 3 over 2P. Q minus half Q plus half Q plus half P minus half Q.